So from this video, we will learn how to write the program code using Floyd Warshall algorithm. It is one of the simplest algorithms in graph theory. It is all pair shortest path algorithm. That means if you have been given a weighted directed graph, vertex 1 may be source and you can calculate the shortest path from 1 to 2, 1 to 3 or 1 to 4. Even vertex 2 can be the source, and using vertex 2 you can calculate the shortest path from 2 to 1, 2 to 3, 2 to 4, and similar you can consider 3 as a source vertex and calculate the shortest path from 3 to others, and 4 can be considered as one of the sources and you can calculate the shortest path from 4 to others. So as it is a all pair shortest path algorithm, the basic principle of this algorithm, which I told in my theory lecture on Floyd Warshall algorithm, suppose you have two vertices I and j and you want to calculate the shortest path from I to j. So the concept behind this one is, suppose there is an intermediate vertex k in between I and j. So you need to identify whether the path from I to j is minimum or I to k and k to j, the entire path, that is I to k plus k to j, this path is minimum. So in this way you can go for implementing the Floyd Warshall's algorithm. So suppose you have two vertices 2 and 4. So in that case you want to calculate the shortest path from 2 to 4. Then you consider 1 as an intermediate vertex. That means the path from 2 to 1 plus 1 to 4, is it less as compared to the path from 2 to 4. So this is the logic behind Floyd Warshall's algorithm. For more detail you can visit my YouTube channel to get the detailed implementations of the Floyd Warshall algorithm. And better it is to solve one sample problem using Floyd Warshall's before implementing the code, before implementing it using any programming language. Okay, so like any other graph algorithms, okay, let us go back here. So k is the intermediate vertex and k may be 1 for this combination, k may be 3 for this combination. So any one of the vertices present in the graph can play the role of intermediate vertex. So 1 may be intermediate vertex, for some combination 2 may be intermediate vertex, for some combination 3 may be intermediate vertex, 4 may be intermediate vertex, and so forth. And the entire algorithm, if you go through the algorithm section, which I have mentioned in my theory lecture, here there are three main for loops. One is the outermost for loop, which is indicated by k here, which indicates the index of the intermediate vertex. So k is the intermediate vertex, and for each intermediate vertex you have to calculate the shortest path from I to j. So k may be 1, so 1 as an intermediate vertex, then you have to calculate the shortest path from I to j. So I and j, these two loops will mainly cover the cost matrix, and it will indicate the pair vertices between which you have to calculate the shortest path. So I may be 1, j may be 3. So you are going to calculate the shortest path from 1 to 3 where the k is an intermediate vertex. So the concept is, for each k you have to treat the cost matrix. K equals to 1 you have to treat the cost matrix, k equals to 2 you have to treat the cost matrix. So that's why k is the outermost loop and I and j are the innermost loop. I indicates the row number, that means for the vertex which you are considering as a source, 1 to 2, 1 to 3, 1 to 4, and j is the column of the cost matrix which indicates the adjacents. That means 1 to 2, 1 to 3, 1 to 4. That means all the vertices who are the adjacent, that will be represented using, that means the column number of the cost matrix actually. Okay, so first of all you have to form the cost matrix, and here the cost matrix formation is very important. Cost matrix formation supports the rule as, if there is no self loop lies between the vertex, that means 1 to 1, if there is no self loop, then you have to put 0. If there is an edge from 1 to 2, yes, 1 to 2 there is an edge, and definitely it has some cost. Unfortunately the cost is not mentioned here. 1 to 2 the cost is 8 here actually. 1 to 2 it is 8. Okay, so 1 to 2 this is 8. So when there is an edge between 1 to 2, you have to put the cost. When there is no edge from 1 to 3, then it is infinity. So initially user will put 0 when there will be no edge in between two vertices, that means I to j. Then user will apply a tricks by which except principal diagonal, that means except principal diagonals, all the 0 entries will be replaced by infinity. So you have to form the cost matrix in such a way, except principal diagonal, all 0 entries in the cost matrix will be filled up by infinity. And if you follow my video on implementation detail of Dijkstra algorithm, you know how to write the macro, that means has define INF 999, using which you can represent infinity. The same concept is applied here also. Okay, now to form the cost matrix, then consider one extra matrix which will be used to store the shortest paths between all pair of vertices. That's why if you go through the algorithm, there is a step which is called the D is another matrix. W is basically the original cost matrix, and D is another matrix which will be used to store all pairs of shortest paths finally. And you know that there are n number of iterations total, so under which there will be n cross n iteration, so at least so finally it is n cube in complexity. So now we will consider the cost matrix formation. So we will take two matrices. One is cost, this will represent the original graph, and another, suppose it is D. D is a distance matrix, suppose. Okay, using D we will go for the computations. So we will keep cost matrix as it is, so we will not disturb the entries of the cost matrix. So first of all we have to build the cost matrix, then we have to apply the formula. It is very simple algorithm and very simple implementations. If you follow this algorithm, that means only 3 for loops are responsible along with this formula, that is d of ij using k equals to minimum of d of ij using k minus 1 comma d of ik plus d of kj, which I told as I to j direct, I to j via, that means I to j direct and I to k plus k to j. So among these two, which one is the minimum, that will be put into the shortest path value between I to j. So using all probable values of k you have to consider. So first of all, in main function we will build up a cost matrix. So to build up the cost matrix, first of all you have to take total number of vertices to form the graph from the user. So if n equals to 4, you have a graph consist of 4 vertices like this one. So if you get n, you can form the cost matrix. Form the cost matrix means you have to consider 2 loops, one I, one to n. This indicates the row of the cost matrix. This is I, this is j. So for j equals to 1 to n, so under which you will form the cost matrix, that means you have to apply the scanf functions. So this is like scanf percentage d, because integer matrix we are considering, ampersand of cost of ij. Okay, so user will put the value. It is my advice to put 0 wherever there is no edge along with the principal diagonal. After that we will modify it. And the modification scheme is like that. So except principal diagonal, I am repeatedly telling it, except principal diagonal, and principal diagonal means row index and column index same, 1 1 2 2 I and j same. Except principal diagonal, all 0 entries will be replaced by infinity. That is our objective. So here we have to write it as if I not equal j, if I not equal j, that means the indexes where I not equal j. I equal j means principal diagonal. If I not equal j and cost of ij equals to 0. So identify row and column which are not equal and check the ith row jth column value. If it is 0, suppose I1 j3, I not equal j, okay, and cost of ij, that means cost of 1 3. If it is 0, then make cost of ij equals to INF. So in that way you can go for replacing 0 by infinity only for those entry where I is not equal j, leaving principal diagonal. We will replace the zeros by infinity except the principal diagonal, and principal diagonal means I is equals to j. So cost matrix formation is done. Then third step will be copy all entries in the cost matrix, that is cost of ij. I am not writing the full code here. Copies cost matrix into distance matrix, that is d of ij equals to cost of ij. So as I and j is concerned, so definitely you should have to consider two for loops here also. So I am not writing in detail. Actually you have to copy all entries in the cost matrix after formation into the distance matrix D. Fine, because I told using D we will go for the computation. We will not disturb the cost matrix. Cost matrix will be as it is. We will implement the concept of Floyd Warshall's algorithm using D. Okay, so first part is over. So the main part is over. After that, point 4 under main function is call the function. Suppose it is Floyd. Call the function. Call the function means the Floyd will act upon D, apply necessary formula, apply number of iterations. Once the part is over, you have to display the output produced by Floyd. So finally display what? Display D actually, because under D all sort of computations will be done, and that will be done with using Floyd. So my advice to declare D and cost both are global, so that once the impact or effect comes under Floyd, so if you display D under main, there will be no problem due to the global nature of D. Okay, so the first part is over. So the main part is over. The function main complete. So first of all, accept the number of vertices from the user. If you have the number of vertices, you can form the cost matrix. Cost matrix basically represent the graph. My advice is to put 0 whenever there is no adjacency. That means there will be no edge in between I and j along with the principal diagonal, because there will be no self loop in the graph. Normally the graph which is been given for solving any problem in this kinds of algorithm, we avoid to put any kind of self loop there. So definitely by default the principal diagonal must be 0, and along except principal diagonal some entries may be 0, because 1, 2, 3 there is no edge, so 1, 2, 3 it is 0. 1, 2, 4 there is an edge, so it is 1. So in that way some of the 0 entries except principal diagonal may be present in the cost matrix. So after putting one value at a time, you judge whether the row and column number of this value under cost matrix are same or not. If they are not same, that means this is the value except principal diagonal. Check the value. If the value is 0, then replace it by infinity. If it is non-zero, then no issue. Non-zero will be remain as it is. Okay, except principal diagonal, that's why the checking is I not equal j, because principal diagonal means I equal j. So we will ignore the self loop sections actually. So in this way you can form the cost matrix. Once the cost matrix is formed, you copy the cost matrix full into another matrix D, because using D we will go for the computation. We will never disturb the cost matrix anymore. Then we will call the function, that is Floyd, which is the responsible function to implement the algorithm actually. Actually the formula that we have implemented in our theory lecture, that will be written inside Floyd actually. So Floyd will accept D for computation, and all sort of modifications or the computation is over, you have to display the result produced by Floyd. So display the D matrix actually. So I told you to declare D and cost both are global, so that you can display it from main also. So now we'll go for implementing Floyd. It is very simple, Floyd FLOYD. What name I have given? FLOYD na? Yes, FLOYD. Floyd. So I am not concerned about the return type. I am not concerned about the arguments to be passed here. This is completely dependent upon you. You will judge whether you will pass the argument, or even you may judge whether you can keep all the variables as global, so that there will be no hazards for passing the arguments inside the functions and so forth. So it is very simple. Again I am repeating the formula which I have discussed in my theory class. This is very simple formula. There are 3 for loops. The outermost for loop indicates the index of the intermediate vertex, for which you are going to calculate the shortest path between I to j. So k equals to 1, because that implies 1 as an intermediate vertex. If you can go through my theory lecture in my YouTube channel, you can easily calculate it, you can easily guess it. So for your reference again, D1 you are forming from D0, D0. Okay, and D0 is basically the cost matrix, because you form the cost matrix, which is G. As per our example, it is cost. D, it is the distance matrix, which will be used for computation. We'll copy G into D. So which we have done here. We have copied cost matrix, cost of ij into D of ij. The same thing we have maintained there. Then you have to go for calculation one by one. From D0 you will generate D1. Then that means 1 as an intermediate vertex. This is the value of k. And for 1 you have to treat the full matrix. That means ith row, jth column, full matrix, n cross n. Then when you are going to calculate D2, actually, when you are going to calculate D2, so you will generate D2 from D1. So again, k equals to 2, you have to treat the full matrix. So this implies for each k value you are treating the entire matrix. So that's why the algorithm is like this. For each k value, k is the outermost loop. For each k value, you are treating the full matrix. So that's why I and j are inner loop. J is the innermost one, I is the first inner, and k is the outermost loop. So for each k, you are treating the full matrix. So very simple, very simple formula. It is very simple. So write the 3 for loops for k equals to 1 to n. 1 to n because n is the total number of vertices in the graph, and any one of the vertices can play the role of the intermediate vertex. 1 may be intermediate, 2 may be intermediate, 3 may be intermediate, n may be intermediate. So that's why k equals to 1 to n. Under each value of k, you have to treat the full matrix. Full matrix means ith row, jth column, 2 for loops, because whenever you are treating the matrix, you have to have 2 for loops, one for row, another for column. So for I equals to 1 to n, okay, because it is a n cross n matrix. Then for j equals to 1 to n, okay, under j you have to write the formula. It is very simple. We have used the name of the 2D array, which is D, that will be used for computation. Initially D holds the cost matrix, so after that we will use D. So it is basically, the formula is D of ij is calculated as minimum of d of ij comma d of ik plus d of kj. So minimum of is if d of ij is found greater than d of I to k plus d of k to j. Okay, so minimum of d of ij comma d of ik plus d of kj is implemented using if d of ij is found greater than this one, then this is the list one, then d of ij is equal d of ik plus d of kj. Okay, done. So on the simple if, simple for loops, and we don't have others to do now. Done. So for k equals to 1, you will treat entire cost matrix n cross n. So I equals to 1, that means I equals to 1, that means for first row 1 up to n, 1 up to n, j. So for k equals to 1, you are treating first row all column. That means you are actually calculating the shortest path from 1 to others using k equals to 1. Okay, then using k equals to 1, you go for I equals to 2, then checking 2 to others, then 3 to others. In that way you treat the full matrix. Then k equals to 2, again I starts from 1 and repeat up to j equals to 1 to n. So for k equals to 2, 1 to n, 1 to n, this is I, this is j. You start from I equals to 1 to n. That means for intermediate vertex k equals to 2, you are recalculating the shortest path from 1 to rest, then 2 to rest, then 3 to rest, n to rest. So this is the way. So for k equals to 1, you can verify, k equals to 2, you can verify. So in that way, k equals to n, you have to move on. This is very simple formula. So you have to declare I, j and k here for implementation. So this if complete, this for complete, this I complete, K complete, and last one Floyd complete. It's a very simple, very simple algorithm. You just write the formula, and minimum of means this is written minimum of means d of I to j, d of I to k plus d of k to j. This is implemented using if. If this one is greater than this one, then which one is the minimum? This one. And if it is not, then d of ij is the current minimum. So in this way you can implement this concept here. Okay, so again I am summarizing it. Form the cost matrix, take the number of vertices from the user, form the cost matrix. User is asked to provide 0 wherever there is no adjacency or even there is no self loop. Then user go for checking the entry which he or she has put. Identify the row and column number. If it is not principal diagonal but the value is 0, then put it as replace it by infinity. So all the zeros entries in the cost matrix except principal diagonal will be replaced by infinity. Cost matrix formation is done. Then take another matrix D and copy all the entries in the cost matrix into D. Then call the function Floyd. Then display D actually. Then the Floyd is very simple. There are 3 loops, I, J and K. K is the outermost loop indicating the vertex which will be play as the role of the intermediate vertex in between I to J. I is the source, J is the target. 1 may be the source, 2 may be the target, 1 may be the source, 4 may be the target. So any one of the vertices can play the role of source. So that's why for each K value you have to check for I equals to 1 to n. Under I equals to 1 to n you have to treat J equals to 1 to n, because you have to treat the full matrix under each K value that I told. And the simple formula, minimum of something means you have to write the formula, you have to convert this formula into the programming statement, like if of this one is greater than this one. That means you are going to calculate the minimum between these two. So which one is the minimum? That means if it is greater, that means if relationship is true, then d of ij is nothing but the summation d of ik plus d of kj. So that means direct path is more than the via path. So in that case the via path is the minimum one. You have to go for the via, that means using k. If it is not, then this relationship is not true, then d of ij is the minimum one. In that way you can treat the full matrix for each k value, and that is the end of it. So dij finally after n number of iterations for each k value, that means k equals to 1 to n whenever it is complete, then you will finally get the d value as the resultant. So in our theory lecture I have told you, that I have this graph. So I have 4 vertices in the graph. So this is z0. So g0 must be copied into d0. So d0 is basically g0. So from d0 you can derive d1. From d1 you can derive d2. From d2 you can derive d3. From d3 finally you can derive d3. Okay, from d3 you can derive d4. So d4 means k equals to 4 actually, as per the code is concerned. So I told probably, yes, I also mentioned here this one. Okay, so when k equals to 4 is complete, you will get final d4. So similarly, as per the graph is here, so there are 4 k values because n is 4. So when k equals to 4 is the last iteration, so after treating the full matrix, d of ij will provide you the updated result. That means it is the final shortest paths between all pair of vertices. That means calling d4 actually, so this is the shortest paths between all pair of vertices. That means if in the main function after Floyd task is over, if you display d, that means all task is over, then actually it is d4 if your graph is this one, that means this one. Okay, so if you read the first row 1 to 1 0, that means there is no self loop. Okay, 1 to 2, that is 3, that is the shortest distance from 1 to 2. 1 to 3, that is 4 unit, is the shortest distance from 1 to 3. 1 to 4, which is 1, is the shortest distance from 1 to 4. Similarly, if you read that second row, 2 to 1, this is 5, this is the shortest distance from vertex number 2 to 1. Here 2 plays the role of the source. 2 to 2 ignore, 2 to 3, that is, you are going to identify the shortest distance from 2 to 3, then 2 to 4, then simply 3 to anyone, 3 to 4 to anyone. In that way, D4 will finally give you the shortest paths for all pair of vertices. So that's why I told you to display D after Floyd method is over. That means Floyd method when completes, so D matrix will finally give you all pair shortest path between all pair of vertices actually. Okay, so in that way you can write the program code. You know the complexity is n cube type, because there are 3 for loops, outermost n, inner two most also n. So with respect to this one, the all inner loops will iterate n times. With respect to this one, this loop will iterate n times. So it itself iterates n times. So n into n square into n, finally it is n cube, which I told in my theory lecture. So my advice again, you all to go for solving one particular problem using Floyd Warshall. Go to the YouTube channel where I have uploaded my video on Floyd Warshall's theory, and we derive the formula, we solve any particular problem, we discuss the algorithm complexity value, you solve one problem, then you go for write the program code and just remember this formula. This is very simple, very simple algorithm, and be careful about forming the cost matrix. Thank you.